Welcome to Product Design and Development. Please make sure to check out the rest of the videos in this course. In this video, I'll talk about Gantt chart, design structure matrix, and network diagram or PERT diagram, which are part of project management. They're part of scheduling, project scheduling, and we'll talk about a little bit of each of them. The examples that you will see and name of some of the tasks and task sequences that you see are from the case study that we use throughout our project management section of this course. That's a injection pen, Biogen Plegridy pen developed. So some of the task names and stuff that you see is from this case study. Please feel free to pause the video and read the information or look up this device online. So three main project planning tools. Again, there are other tools, but these three are the more commonly used in industry. Especially Gantt chart is widely used because of their simplicity and how easy they are to use and a great visual way of representing tasks. But for some major companies or major projects, design structure matrix might fit better, and PERT diagram similarly might fit some project better than Gantt chart. But again, all of them, they kind of show a little bit of task dependencies. Gantt chart a little bit less. But it's a good visual representation of tasks. Design structure matrix, it shows task dependencies, same as PERT diagram, but PERT diagram, it shows something known as critical path, which identifies which tasks are critical in the project and in the project timeline. So we'll talk about each of these in the next few slides. Starting with Gantt chart. As we talked about it, a very quick, good visual representation of tasks and the project. So tasks are listed here in a column. They might have a number, they might have a letter associated with them. In this case study, every task has a letter because we're going to use them in PERT diagram and DSM later. They also have a duration listed here, each task, again, whatever the project might be. In this project, each of these durations are in months. And on the x-axis, this is usually the time, and it could be based on years, quarterly, which you can see here, or it could be monthly, depending on the project length. And then duration of each task is kind of shown by a kind of a bar. So it's duration of each task. Sorry about the bad handwriting. A line usually represents the current date, and how much each bar is filled in, that shows percentage of completion of the task. So by just quickly looking at this graph, we see that task G is a little bit ahead of schedule. You can see tasks all the way to I are pretty much done. They're all done except with the exception of task G, which is already ahead of schedule. Task J, when you look at it, that one is right on track because the percentage of completion and current date, they match. And then when you look at task I, you can see that this is maybe a little bit behind. It should have been filled this much already with the current date, but you can see it's a little bit behind. So again, very good quick representation of how much tasks are completed and where we are in the project. The problem with this is when bars are kind of overlapping, you don't know are they sequential, parallel, or even coupled looking at the Gantt chart. So you got to go back and look at the delivery information. So this doesn't show you how data is transferred between the tasks. Here's another example of a Gantt chart. Again, it has other information in it. It has dates of each activity and end dates of activity. It has kind of subtasks built into it a little bit, expandable, tasks. It included resources, included a little bit of task dependencies, which I like. This is a little bit better because you can see some of the task dependencies. There are a variety of different templates online. Excel has some templates, or you can just build your own. It's very easy to build this one on your own in a spreadsheet. So that's one of the reasons of widespread use of Gantt charts. Moving on to the next one is design a structure matrix, or DSM. This is a matrix. Tasks are listed on rows and columns. So you can see the tasks are listed both on the rows and column, and then the diagonal shows also names of each tasks. Every time you see an X, that shows a task dependency. What does that mean? That means these are the tasks that depend on each other. They require deliverable and transfer of information between each other. If I'm reading across a row, if I'm reading this way, reading across a row, when I see an X, that means it reveals that the task that needs to be done before the task in the row. Reading down a column, if I'm reading this way, reading down a column every time I see an X, that means reveals that the task reveal the task that receives information or deliverable from the task in the column. Okay, so let's quickly look at it. Reading across a row, for example, let's pick task H. I'm reading across the row, I keep going, I see an X. This shows the task that needs to be done before task H. So task D, E, F, they need to be done before task H. Let's say I'm reading across column. Let's look at task F. I'm reading here. I see task D, E, task H, J, K, L. These all need to receive information from the task in the column. Now you see these borders. You see these borders around some of the tasks. So when you see an X above the diagonal, when you see an X above diagonal, means two things. Could means, hey, if you reorder the tasks, maybe the order of the tasks are not correct. Maybe if you reorder it, then the X might disappear. But if you reorder them and the X is still showing, then you know that those tasks, it shows coupled tasks in in the your matrix. So in this case, G, H, I are coupled, D, E, F are coupled. Sorry, D, E, F are coupled, and J, K are also coupled tasks. Usually there are optimization and project management softwares that will optimize and reorder the task if you have hundreds and hundreds of the tasks. So you are sure that whenever X shows up, it's coupled tasks and not just ordering issue. Here you can see an example. I mean, it's really hard to see the names of the tasks, but that's okay. The names are not really relevant to what we are discussing here, but you can kind of see for a more complex project with a lot of more tasks, instead of dots, again, instead of X's, they use dots here, but that's pretty much means the same thing as our task dependencies and how tasks are related with each other. And then the last part of today's video, I'll talk about PERT diagram. Program evaluation and review technique, PERT diagram, also known as network diagram, also known as critical path method. In each of these, we show usually tasks with a border. It's either a circle, a rectangle, a square. Tasks are shown. Inside each task, duration of the tasks is shown. Arrows show flow of information. Again, this is flow of information, flow of data, flow of deliverable, and one of those paths are kind of highlighted, showing as a critical path. Critical path means the longest chain of dependent tasks in your project. After you draw up your PERT diagram, the longest chain of dependent tasks. And this doesn't just mean how many tasks are there. The longest means longest time, not the number of tasks. It also means this is the minimum possible completion time of your project. It's not possible to finish the project before this time. So we'll talk about this a little bit. So this is again from that Plegridy pen example that we had. We talked about it a little bit in task list development video, but you can kind of see here, again, arrows show flow of information, flow of data, flow of deliverables. It's either name of the task, or they can just put letters instead of this. They could just say A, B, C, and so on. This is the duration of it. In this case is in months. Okay, when you look at this is coupled tasks. Means these tasks are mutually dependent upon each other. They all depend on the previous task. They all give deliverable to a future task. This is also a coupled task. These tasks right here, I'm going to put a little border around it. These are parallel tasks. Okay, and there are sequential tasks. These are sequential here. These are sequential tasks here. So this kind of, again, a graphical representation, but in this diagram you can exactly know what task dependencies are. But then if you consider the timeline, the path you're taking, if you take 12 months here plus the longest of this one is 12, going into plus 1 plus 6 plus half. If you add all of these together, the one that are in the critical path, 12 plus 12 plus 1 plus 6 plus half. This is the shortest possible completion time. I did not add these all together, because these are parallel, means they're done at the same time. And so the overall, all those 3 tasks is gonna take 1 year to be done. One of them is going to be done in 3 months. That's fine, but the other 2 is going to take 1 year. So the path that is highlighted, that's the critical path. That's the longest chain of event, but it's also the shortest possible completion completion time of the project. Here's another example with some, again, codes. So these are all tasks, names, and kind of code name for them, or letters. And again, same as before, you have duration, you have task. This is flow of information, flow of deliverable, flow of data. This is critical path. So if you add 2 plus 4 plus 8 plus 2 plus 14 plus 10 plus 4 plus 2, this will be the shortest possible completion time of the project. This is in weeks, by the way. I want you to just point out to one thing when we talk about critical path and critical tasks. Let's look at these 2 tasks. Task D is on critical path. Task E is not on critical path. If that task D is delayed, let's say by 1 week, what happens is task 8 is right here. If this is delayed by 1 week, it delays the entire project by 1 week. So that's the importance of having this task on, having this method, this visual representation, because it tells you what tasks cannot be delayed, what tasks are important. Let's say if task E is delayed by 1 week instead of task D. Task D is going to be on time. Task E, instead of 5, is going to take 6 weeks. That does not affect any of the project time. Your total project time is still going to finish on time. So if, for example, you're project manager and you see task D and E, both of them are kind of falling behind a little bit. As a project manager, you look at your critical path and you realize task D is the critical task. So maybe you remove some personnel from task E, put few people more on task D to make sure this is not delayed, because task E, you have a little bit of flexibility in maybe working around the timeline that's developed for. So this is the importance of critical path and critical tasks. And this is a beautiful way of showing which tasks are critical and cannot be delayed, because they affect the entire project. Thank you.